so that we do an example just to remind ourselves of this formula. The formula that was very important during that class of last week. It was yesterday, the other day. So again, I'm very sorry we didn't meet yesterday night. I had power issues. So it was supposed to be chemistry. I know you were told, but we could not because there was no power in my area. So Madam took over. But this morning now we can continue. Although we are a little bit late, I thought we would have gone a little bit further because we are, I think, around 15 or 20 minutes, around 15 minutes into the lesson. But it is okay. I think the remaining time is enough for us to complete something. Now, these two formulas that I've just circled are very important, so important that I want us to do another example. We're going to do one example. I think we completed all these examples except number 4. So let us do question number 4 as we remind ourselves of how we solved it the other time. So we are saying calculate the molar mass of an element if a mass of 5.6 grams contains 0.1 moles of the element. Now, the element now, in this case, the molar mass is not necessarily given because we can calculate the molar mass we can calculate the molar mass of that element, and then we can even name the element ourselves. So let us try that one down, and then we see. So we're calculating. So what we do is we use this formula. We are calculating the molar mass. So in that case, we are choosing this formula that I want to have circled. The other time, I said, if you cannot remember the triangle, you have that triangle, which has something on top this way, and then it has, let me not write the molar mass and the number of moles. Let me just use A, B, C. If you don't know how to use this triangle, like I mentioned the other time, please shika moja. Unaweza shika hii ama ushike hii. All those things can be manipulated so that you get the answer. The reason why I'm stressing on this is because of the empirical formula and the molecular formula that we are going to do. So if you cannot remember hiyo maneno ya ABC where you have molar mass, and number of moles in the triangle, please shika tu hii ingine. That one is very important. I'm just saying that because of confusion that normally comes using this when you use this one. But there's no problem. So we are calculating the molar mass. So you know that this one now is the formula. Molar mass is equal to mass over the number of moles. So we have the mass. This one is the mass. I'm just doing it for we're just trying to remind ourselves because the same relationship between the RMM and the mole, we'll be only changing a very small thing. So that is why I want us to do this one. And this one is the mole. So you know that molar mass is equal to mass over the number of moles. So this one now becomes 5.6 over 0.1. So of course you can multiply this one by 10, or you can use the calculator, and then you'll find it is 56. 56. Now, the molar mass actually might not be having the units, but we know that it should be what? Should be in grams. So it is 56. Now, the question sometimes will be asking you, what do you think that could be? So when they ask you which element this could be, this one normally comes especially in the what do you call in the practical. Wanakulizanga, you calculate the molar mass and then they ask you unadhani inaweza kuwa nini. So that one is very essential. I just wanted us to remind ourselves. So today, actually, what we're going to discuss is the relationship between the RMM, which is the relative molecular mass or the relative formula mass. I normally repeat that one so that people that don't get confused. Again, this one will be using somewhere else. So the relationship between relative molecular mass and the mole. Now, I think that is the only subtopic we're going to do because it has a lot of calculations. In fact, if time allows, because we're only remaining with a few minutes, we'll do something else. So the relative molecular mass of an element or a compound is the sum of the atomic masses, the relative atomic mass in the molecule of the element or a compound. For example, chlorine zikiwa mbili, we are done this one. So we are saying because there are two now, we are multiplying by 2. Or nilisema if you cannot multiply, we are adding it. So it is like this one, you multiply by 2 or you add another 35.5. So you choose your poison. But I normally advise people to choose the poison that will not kill them. So you choose the poison that will not kill you. That is why you see this one, it is 1 multiplied by 2. The only downside of this one now, when you have a very long formula, for example, you're given an alcohol. Yeah, you're given an alcohol. Is alcohol is very long. It is ROH, yeah, or you're given an organic compound. So you'll find the compound is very long. Now, if you do multiplication and by mistake you don't do this and you feed them in the calculator, you'll get it wrong. So kama ni alcohol, you can say it is carbon is 12 plus hydrogen 3, so it is plus 1 plus 1 plus 1. We'll see an example. Instead of 1 multiplied by 3, but remember when you do that now, you must use the bracket. So sometimes the bracket you can get confused. If you get confused that time, it becomes problems. So unaweza lose marks because of some small mistakes. So if you are deciding to use the multiplication, you be very keen. That one is very important. Now, so we want now the relationship. So when you add this one, sum actually is addition. So when you add all the relative or all the atomic masses of the individual now atoms zenye zimecombine zikaform the compound or the molecule, now whatever we get is what you call the relative molecular mass. Now, so when you talk about the molar mass now of chlorine, the relative molecular mass is 71 for chlorine, the RMM, or what you call the relative formula mass. And then of water is that we'll do more. We'll do more about that one. We'll do more examples. But now the best way of understanding how this one comes in, I do not normally even explain. I do not normally explain most of the time about these things. Literally, we normally just skip. I normally skip to the formula and then I show how it is done, the calculations. But for our case, no, I decided no. Let us just do. That is why now I'm not using my actual notes, but I think I'll still open them so that you see. For any compound, the term relative formula mass is used. Yeah, are you seeing now what I was talking about? Okoju. The relative formula is the sum of the relative. It is the sum again of the atomic masses of all atoms in the formula unit of that compound. For example, potassium sulfate, we have 2 potassiums, we have 1 sulfur, we have 4 oxygens. So you add, and then now you have the molar mass. So it is the formula now for that case. When you have a molecule, it becomes molecular mass. I don't know if you're getting the difference of that thing. Now, but most of the time, I normally advise students, you can use both, but make sure the calculations is correct. Because we have molecules and we have compounds. When you have compounds now, that means you are getting something else. But all of them, it is the formula mass. The most important thing when you're doing that one is the mass. Mass. Yani ujue mass, and the mass that we're using is always in what? It is in that. So the RMM is used when you're talking about molecules most of the time. And then we have the formula mass is used when you're using those ions that are coming together to form a compound. But I'm saying sometimes you're in a rush in an exam room. So the most important thing to remember is the mass. Yes, mass. That all of them are in grams, and it is mass. So, so what is important now? Yeah, is 1 mole of a substance is equal to the 1 mole. Let me write now. I'll just write and then we will continue. We have that exercise 2.4. 1 mole is equal to the R. So we have the RMM, which I am using as the relative molecular mass, or now itategemea RFM, RFM. But all of them, they are equal to what? 1 mole. That is the relationship of the mole and the RMM. Now, remember, sisi tuko tumesha calculate molar mass. So if you are given a mass again, you can get RMM or the RFM, which I am using these initials for the relative molecular mass, and the RFM to be the relative formula mass, is equivalent to the mass that you are given at that particular time, depending now on what you're calculating, over the mole. So it is the same thing that we did Apoju, the number of moles. The only thing that will be changing maybe is now we'll be talking about a lot of things that are combining together. Yeah, we will see that one. But this one now is the main relationship that we wanted. The relation, because we are talking about the relationship between moles and RMM or the RFM. But this one again can be used now when you're calculating the mass. For example, you're calculating the universal mass with, unless you ask about the individual elements in that particular formula. That one we will see again. That one is very important. So let us do an example so that we see. But this one is the one that we'll be using. So let me wrap this one. And then we see. So we'll solve more, and then we see if we understand. Now, so the copy and complete the table below. So it is now. Remember when we started this? When we came to this class of chemistry, I remember I said the name of the compound is not really as important as knowing the formula, chemical formula in that case. So I said it is very important for you to know the chemical formula of compounds of elements. Very important. So I hope that thing has changed. What wajue, the chemical formula. It is very important. Now, for example, name of the compound is carbon peroxide. I want you to let us do what I will do one, and then you can do another one. So we will be exchanging. So we have the name of the compound is carbon peroxide. Now the formula of the compound of carbon peroxide is CO2. I am trying to write it the correct way, like I'm using a pen. Because if you don't write it the correct way, it will bring issues. Now, the molecular, you see now those things are moving together. The molecular and the formula mass, zote zinatembea pamoja. So you should not be worried. Now, so we have carbon. We know carbon is 12. So the molecular mass, or in this case, now the molecular mass is 12. plus 16 plus 16. So inakuwa ngapi? So the molecular mass now in our case is 44. That is how we get the molecular mass. You add the sum. So we have 1 carbon and we have 2 oxygen. So you add the individual atomic masses. Whatever we get now is what is the formula mass or the molecular mass, depending on what you're given. But I'm saying both of them are moving. Hizo vitu zinatembea pamoja. So it is very important for us to know. Another one is HCl. So I don't know. I will be doing you can do for HCl. Let us try. Let us try. Or I do for HCl and then you do for the carbonate. You just decide. Let us try one. Yes?
It's okay, teacher.
Yeah, let us do for we can do 2 or another 3 and then we go to something else. I don't know now if you know the individual RAMs. For example, for H is equal to 1. So I'll just write H because this one is normally given. I don't know if ama iko chini. Let me confirm kama umepewa hapo chini. So I just have to move this one. No. It is not there. So I just have to give them out. The only problem of moving now after writing is the word does not move with the. So after this, we are going to the empirical formula. So it is very important for you to know, first of all, if somebody has not understood the first thing that we did and the second, which is now the relationship between mass and moles, and the relationship between RMM or the RFM and moles, hata hakuna haja tuende empirical formula. That's what I'm saying. There's no need. We better start again. So because you cannot solve the empirical formula and the molecular formula without knowing this. So I'm just going to randomly H is equal to. So I think somebody has posted something. HCl is equal to, yeah, Maura. I think I'll still talk about that one. So I have one answer. I don't know if somebody else is willing. I wait for them, or I just solve it. So I'll give you this, Maura. Let me give you something, and then you check if you are changing your answer. H is equal to 1. Cl. Now remember the mass that we are using is not the atomic number. We are using the mass number. So that is why I'm giving you this. Are you willing to change your sodium? I'm interested, especially in the ones your sodium. I want you to solve for me your sodium. I'm interested in something. Sodium is equal to 23. I think C is equal to 12 because most of the time we are using carbon 12. You must check, but most of the time we are using carbon 12. And then we have O is equal to 16. This one, ni ya hii. This one, both of these, ni ya huyu. Yes. I'm interested in especially knowing something, especially for sodium. I'm interested in the formula. Now, if you get the formula wrong, that is the chemical formula of that thing that you are given. Kama formula ni wrong, then your answer is automatically wrong. Yani, kama hujui kuandika formula, you will not get the answer. I'm giving people. Let me just give you a few minutes to try. I'll do another one because I must do another one. We have a lot of questions. There's a question actually yenye iko huko chini that I'm very interested in more. So I think I'll solve that one. So should I still give you some few minutes or I just solve it so that we don't use a lot of time and we only remaining with a few minutes like 20. I know people wanataka kwenda jobs and the rest. Maura, are you changing your answer for HCL? Of course, I'll give the formulas. I'll give you the other formulas so that you can try also. But it is very important, like I have been saying, it is very important for you to know the chemical formula. How to write the chemical formulas. And it is normally, yani kitu si ya kuguess, inafunzwa. You should know how to write them. Of course, in Form 1, we talk about the word now, but when you come to Form 2, you'll be talking about the chemical formulas. So it is very important for you to know how to. So let me solve for HCl. It is normally HCl. And I am saying you should not be worried about how this one is. How to you should not cram maneno za what do you call it? Maneno za RAMs, the individual RAMs, relative atomic masses. It will always be given in bracket. Now that one is HCl, so you'll have. I think that one is now. It is easy. It is one hydrogen, one chlorine. So the answer will be 36.5. 36.5. Please do not use the atomic number. That is, do not use the number of that particular, let me say, element or atom in the periodic table. The mass number actually is the mass of protons plus neutrons. But the one now that is in the periodic table is atomic number, which is only the number of protons. And the protons, I said, is equal to the number of electrons. That is why unapata hivyo. So sodium carbonate, I'll give you the formula. Let me just give the formulas for this one. I'll solve maybe two, and then I solve the ile yenye iko chini. Sodium carbonate is normally written this way. Carbonate is a radical, so it has a radical of 2 negative, a charge of 2 negative. So you're supposed to phosphorus 3 negative, sulfates is 2, chloride is 1. Which other radical? Chloride is not a radical. I'm just using that example. Carbonate, sulfate, which other one? But you should know those things. It is taught. Calcium chloride. So can you give me the mass of this one now? So I've given you the name. Calcium is in group 2. Sulfur 4 oxide is SO2. Ammonium sulfate is ammonium, not ammonia. It is ammonium. 4, and then the sulfate nimesema iko na 2, but ammonium is positive 1. So this one is wanasemangaje, not a fertilizer. You know, we are used to saying phosphate ni fertilizer. So it is this one is fertilizer. And ammonia is written that way. So we can only solve one. I'm interested, especially the ammonia. I will solve ammonia because of something. So I think I'm giving you maybe 2 minutes or a minute to solve for this one because I've already written. So we have 2 calcium, not 2 calcium, 2 sodiums. So you can do, I am advising people to use this one. 23, and there are 2 plus 23. So that you don't use any bracket. Plus, how many carbons are there? 1. Plus 12. Plus, how many oxygens are there? There are 3. So it is 16
times
plus
3
16.
plus 16 plus 16.
Yes. So I'll advise you to use this one. You see, this one is now you will not mess. You'll just do it. So I don't know the answer.
106.
106. Now let me tell you something now about maneno ya RFM and the RMMs. And the only problem with this thing is you mess up hapa. Tuseme usahau hii 2. Ukisahau 2 and you remove 23 from this one, the answer now becomes wrong. So you are supposed to know the formula. If you don't know the formula of the compound or of the molecule, you are in for a bad day. Very bad. The answer that you will get, you will lose all the marks because of now losing, not understanding how to write the formula. That is what I've been saying. It is better for you to know how to write the now. So we have gotten that one. I want to do. Yes, somebody saying something. Yes, I want to do. Yeah, or I will give you another one. Yeah. Let me do. Can you do ammonia, or I want you to do ammonium sulfate. I can do for calcium. Yeah, I think I can do for calcium. Atomic mass for calcium, I think it's around 40, or I think it is 40. Yeah, I know calcium is number 20, but it's that one. So calcium, so I can put here Ca is equal to 40. It is normally 40.00 something, 008 or 009, there about. You can confirm. These things can be found in the. They are normally in the periodic table. If you have the periodic table, unapendwa tu kitabu. Most of the exercise books actually normally have the periodic table. Ama katikati, or the text, any chemistry textbook have the periodic table. And then chlorine, do you have chlorine? So calcium chloride will be 40. It is 1. But now the chlorine is 2, 35. So it is very important for you to know how to write plus 35.5. Now, when you are doing, especially those ones that have decimals, when you are using the ones that have decimal places, kama hii 35.5, make sure you check the value that you have been given in that exam, because sometimes the teacher anataka kukusaidia maisha ikuwe rahisi, ameweka 36, but you decide sisi tulifunzwa na 35.5. So you check the formula that you've been given, the mass that you have been given in that. Now, so it is 40 plus this one. This one is 111. I don't know. Is it 111? You can confirm now with your calculators. Now, I don't know if you're okay to solve for me this one. I want people to solve for me for ammonium sulfate. I want this one. There's a reason why I want this one to be solved. I'll give you. So you have nitrogen. Nitrogen inakwanga ngapi? Nitrogen. I don't know. Is it 15? Nitrogen is number 7. If it is number 7, then it is 14 because we're adding two things. So nitrogen is equal to 14. Hydrogen is equal to 1. So you tuko nayo. Hydrogen is equal to 1. Sulfur. So you have sulfur is equal to 32. It is number 16, eh? And then oxygen is equal to 16. It is number 8. So, and most of these ones you'll find that, except a few, the number of neutrons are equivalent to the number of electrons. I don't think people know that. Very few is different. Now, I don't know if you're okay to try this one so that I can solve something else in an hour. Of course, this one also will affect this one. It affect both of them because you have nitrogen and hydrogen. Muko sawa solve the two, not the one.
It's okay. Plus the sulfur oxide.
No, just leave that. That one is very easy. That one I can solve for you. I think it is 32 plus 32. Because oxygen are 2, which is 16, 16, and then sulfur 32. So munawacha hiyo. I went for ammonium sulfate. Ammonium sulfate especially. Let me check. Somebody has posted something so that I can also. So ammonium sulfate you're saying is 114. So you have one answer. I don't know if others are solving or I can just continue because I was interested in knowing if people can solve them. So let me try because of time very quickly. So we have nitrogen to be 14. So the reason you are supposed to, so nitrogen is 14, but how many nitrogens are there? I want you to see these closely. It is 2, so it is 14 marambili. Yes. And then we have hydrogen ni nne ndani, lakini ni mara. So allow me now to use this one because of the space. 1 multiplied by 8 is 8 hydrogen. So that we see plus sulfur, which is mepeana 32, plus 16 4 times. 16 multiplied by 4. So the only downfall of this one, of using this method that I have used now, is usahau kutumia bracket. It will give you a different answer. So this one is 28 plus 8, 32. No, 36, eh? Now I don't know. Now you can give me the answer. I don't know if it is on 14. But it is very important for you to know how to calculate this one. It is very important. So I don't know, those who have calculators, let me try also using my phone. This time I'll use my phone. So that we move a little bit faster. That is 28 plus 8. So that is 36 plus 32.
32.
132. So have you realized where you messed up?
Yes.
Yes, it is. So that is what I'm saying. This one now is very critical. If you mess up somewhere, you never get the same answer. And if you don't get the same answer, that means you get it wrong all through. Yeah. So it is, you should be very keen, especially when you're writing formula. In fact, unajua calculate the molecular and the mass formula is not a problem. Where all these problems start, ni hapa. Can you write the correct formula? For example, ammonium. Ammonium, you see sodium carbonate now, most people might write sodium and carbonate without you adding the two on the sodium. Then you'll be having a lot of problems. Now, I hope you're okay up to that page. I want to solve maybe two last questions, and then we call it a day. Because now the morning class I normally say is very short, but I think it is normally better than the evening class. I don't know. I normally say people maybe could be tired because of the day's work. So the morning class is also very nice, but it is very short. Maybe I normally say maybe sometime. But that is just a thought. If we start earlier, it becomes better. Now, I'm not going to start the empirical formula. I said the empirical formula will need its own day. And then, so we are not going to start that one today. And furthermore, we only have a few minutes. So, how many moles? Now, this question, let me solve question 3. There's a reason why I want to solve question 3. Now, the reason I want to solve question 3 is because this question 3 now ni ile maneno nilikuwa naambia ya alcohol. So alcohol, they give you a very long formula. So if you don't know how to, so at least you thank God this one they have given you the formula. And it is ethanol. So ethanol normally have either ethane, so it is 2 carbons, which is here. So hii sasa kwa alcohol, you'll find that it is what we call alkyl group, ethyl. So this one is ethyl. And then this one is the alcohol, active part of the alcohol. But this one will do it in, so this one is ROH. That is why I'm be saying ROH most of the time. Inamaliza zote, inaguza methanol, ethanol, propanol, butanol, all of them. They can, yani inaguza all those things that have an alkyl. So this one is the alkyl group. We'll explain how an alkyl is formed. It is normally an alkane. When you minus one hydrogen from that alkane, inakuwa alkyl. Ukitoa one of the hydrogens from it. For example, nikiongeza hydrogen hapa inakuwa C2H6. That one now is ethane. Lakini ukitoa moja minus 1 ikibaki 5 inakuwa ethyl. But we'll talk about that one another time. That one is, so anyway, so do you think you can give me the mass of this one so that I can solve the question?
Yes.
For example, yes, I'll give you the C is equal to 12. Yes,
H is
equal to H is 1, and oxygen is, so this one is very easy. Oxygen is equal to hydrogen is equal to 1, and then we have oxygen is equal to 16.
That is 40.
40. Yeah, so it is, this one is 24 plus 6. Is it 24 plus 6?
Oh, sorry. That is not 40. It is 24 plus 5 plus 17.
Yes. So if you mess up that one, in fact, the answer you'll get will be different. And if you get a different answer, that means you are wrong. So what is the mass? RFM, or it is the RMM now?
46.
46. So we can only do, so this one is 24 plus 6 24 plus 16 is
Plus
40.
5.
Yeah.
Mm.
Well then, yes. So it is 46. Now, but that is not the answer to the question. So this one only will give you the RFM. Yeah. So what is the
10
mass? Yeah. So nilisema unasema mass. So
equals
we have the moles. We have the moles. So you can use this. You choose the formula now that will affect you. So tunasemanga moles, you can use for the number of moles. Nilisema it doesn't affect anything. Now let me show you why it doesn't affect anything. The easiest one is normally number of moles. Number of moles is equivalent to mass over RFM. Sindio? In that case, it can be RFM or RMN. Now, if I have this one, I can just equate it that way. Yani nikishika hiyo peke yake naweza equate to the rest. I don't even have to change to make anything the subject of the formula. So we have the number of moles is 0.2 is equal to what are we looking for? Mass. Do you have the RFM? Yes, we do. Over 46. So I can just put it that way. So there's no problem. So that, but this one now you multiply, still cross multiply. And you remember this one is over 1. So it becomes 0.2. You multiply by 46 is equivalent to the mass. That is how you solve it. But remember, if you get a different formula mass, everything will change. Everything. You will get a different answer. So I don't know how much this is. So what will be the mass?
9.2 grams. 9.2 grams.
So the mass now, that makes up 0.2 moles. Now I'll explain this one this way. 9.2 grams. I want to explain this one this way. Niseme hivi. This way very slowly now. If I wanted to make in the lab 0.2 moles of ethanol, what I do is napima na weighing balance, yeah? Or the weighing machine, or whether it is digital, the old school, I am weighing 9.2 grams na niweke kwa 1 liter. This one I'll explain in making molar solutions, but I just want to say this one because we are here already. So if I wanted to make 0.2 moles of ethanol, napima na niko na vitu in grams. So napima 9.2 grams of ethanol na niweke kwa 1 liter of water. Whatever will be formed is 0.2 moles of ethanol. That one is for another day. Let us just do one ya mwisho. How many moles of oxygen atoms are there in 1 mole of copper 2 sulfate? I don't know. This one you can do, eh? This one can be done by you. So the moles, this one you can do. But I'm not interested in that. That one is very easy. I'm interested in question number 5, actually, which is saying, what percentage by mass of sodium is there in 1 mole of sodium nitrate? And they have given you the. So nasema mshukuru wakikupea. And this one, you normally, for those who are taking agriculture, I hope there's somebody who is taking agriculture. If not, this one has been done. You normally get the percentage of the, is it what? The nitrate. They normally ask the percentage of nitrate most of the time, especially in the fertilizers. So this one has been done. So what you do, I'll give you sodium. Let me do this one as the last question. When we meet, we'll start with the empirical formula. I hope madam will be there. I think it will be on Saturday. Now, this one is enough. Saturday will be enough to do empirical formula alone. So that people can understand. Then maybe on Monday night, we finish the molecular formula. Then we go now to the molar solutions. So sodium is equal to 2,3. So I'll give you this one so that you give me the mass. So that I tell you how to do the percentage. Nitrogen is equal to 14. And then we have oxygen is equal to 16. So you can give me now sodium. So the RFM, the relative formula. This one is formula mass, because it is ions being combined. We are combining the sodium ion, sodium cation. Let me just use those words: sodium cation and the nitrate anion. So nitrate is a radical also, but now with a charge of 1. What do you think is the RM as we end this lesson for today? So that I tell you how it is done. This one is very easy. But we'll do, I think this one more will come in the other side. Itakuja pia kwa okay, this one is older one. Because of time, I think I can give the answer. So then is 23 plus
85.
14, 85. Yeah. So this one is 85. Now, how you normally solve this one? What percentage by mass of sodium is there? When you talk about percentage by mass, they're asking us to calculate the percentage of sodium in that one. So what you do in that one, the percentage of sodium, this one is the last one, of sodium is equivalent to the mass of sodium or mass of that particular one. They are asking you, mass of, in our case, is mass of sodium, mass of sodium. So don't mind that one, just slipped. Mass of sodium over the RFM, and because we are talking of percentage, because the percentage you multiply by what? 100%. So percentage of sodium, so we have, what is the mass of sodium? Ulikuwa umepewa 23, so it is 23 over, nimeandika juu because of space, over the RFM, which is 85, and then you multiply by 100. So that is how you do this one. Whatever you get now is the percentage by mass, and the answer is in percent. Si tumeleta percentage ikuje. So we can solve that one, and then I'll give you, I want you to try, can you calculate the percentage by mass of nitrogen in the same question? 23 divided by 85, multiplied by 100. That is, should be 27 point something, huh? So it is 27, yeah, 0.0 something.
27.06.
Yeah, 0.6%. Now, for that one is actually how you do the percentage by mass. The reason this I must do this question is because it will be used somewhere. It will be used up in the empirical formula. So you should know how it is done. Now, can you try in the same question? Can you calculate the percentage by mass of nitrogen? And then I think I can be wishing you a nice day as you continue. Have a very nice day. Have a very fruitful day. May you all your days, all your work be successful today. Yes.
Nitrogen, 1 mole of nitrogen, sodium nitrate,
Yes, it is the same question. I'm saying we are looking for the same question. We are doing question number 5. But now what I'm asking is we try to get the percentage by mass. Instead of sodium, I'm putting nitrogen. Yes.
Okay. Okay. Then we send.
Yeah, I just want us to see kama tumeelewa you, because we are going to use it. And because of time, I want to wish you all the best. Have a very nice day. I know people are going to prepare to go for work. So mkuwe na siku njema sana sana sana.
Yes,
unless there's a
yes.
query. Yes, unless there's a question, then you can just leave. I think that is the end of today.
Okay, good day.
Good day.
Yeah. Cha kama hujaenda ni 16.47.
I think I'll do it. I think it is okay. I think that could be the answer. Because it is 14. So let me do it and then I can give you the feedback as you leave.
Yeah.
It's 14 divided by, is it 14 divided by 85?
Yes, times 100.
Yes. So that is how we solve those things. Actually, you're correct. 16.47. That one is correct.
Mm.
So that means the percentage that remains in that in that one is the percentage of oxygen. The only remaining atom, or in that case element or molecule. So that is the percentage. So the remaining percentage, and ukitaka kujua you are correct, you can calculate the percentage by mass of oxygen, and when you add the three, they should be
It
adding
is
up to 100%.
Oxygen 18.82%.
18.82%.
Percent.
I don't know what was the mass of oxygen in that case. 60 something. I don't know, or 40, 48.
Oh, sorry,
Is it?
it's 48, not 16, eh?
Yes.
It
So
is
48.
56.47.
Now,
56.47.
so 56.47. Let me add, and then we have the other one was 16. Is it 16 or something? I want us to add all of them so that we see if it is adding up to 100.
Okay. So
56.47 plus
56.47 plus 16.47
16.47
plus
plus
27.06.
06. Is it adding up to 100%?
100%.
Yes. So ndo ujue uko correct, you add those masses. Ukipata yako unapata 300%, then you are wrong. Or if you get that you're getting 50% or something that is not close, you can get 99.9 something because of the rounding off and the truncation that you're doing. But if you get something that is more than 100 by 110, 120, you have a problem. But if it is
But point
100.00 something or 100.1,
it's
99.9, then it is okay.
okay.
Yeah. So you have a very nice day. So when we meet, I think empirical formula and the molecular formula.
Okay, thank you so much.
Yeah, thank you very much.